Hello, my name is Bill Cope, and I'm going to speak to some ideas that Mary Calantzis and I have been working on about the nature of the humanities, in fact, the meaning of the human in the era of what we call algorithmic reason, this digital era. Thank you very much for inviting us to speak at the conference. We're very pleased to be here in this kind of very post-pandemic or pandemic virtual kind of mode. So thanks for inviting us and giving us the opportunity to share some of these ideas. And what we're going to do in this talk is firstly talk about artificial intelligence. How does it work? What are its mechanics? What kind of media does it produce? And in the second part, we're going to just think in a brief kind of way about the nature of the human and this now frequently used phrase or term, the post-human. So, conceptualizing AI, what are its mechanics as media? And this is kind of a short summary of where we're going to end, in fact, but then I'll try and flesh it out and explain in more detail how we come to this conclusion. Computability is the transposability of meanings into calculable quantity. And we're going to work on two definitions of artificial intelligence. A broad definition is meanings that are made with more calculation than will be feasible without mechanical intelligence. And this phrase, mechanical intelligence, is the phrase that Alan Turing used. I'm going to talk about that in a second. There's also a narrow definition, which is now the more frequent definition of artificial intelligence, which is about synergistic human-machine relations in the world of machine learning. Not only are you using the machine, but the machine is learning from your using it. Now, in fact, in terms of the history of ideas and machines and practices, this is by no means a new idea. Famously, Leibniz said, that we'd be able to think by numbering everything in the world and calculating. We'll be able to come to definitive answers to questions about the world. This is the famous Leibniz formulation. And then moving on into the 19th century, we have here on the left Ada Lovelace, who one day, being a kind of a child of the English ruling class, was able to go to a soiree at Charles Babbage's house and saw this analytical engine on the right there. She published a famous paper in the late 1830s, and this is a small fragment of it on the right, but one of the things she said is by mathematical representation and calculation, it may be possible to express some of the meanings of the world. That's essentially what she's saying. And her conclusions about this logic were based not just on her seeing Babbage's machine, but she and her mother had toured northern England and seen these looms at work. This is a jacquard loom, which is producing these remarkably beautiful patterns from nature. So in a sense, the idea of a programmable machine, which produced meanings which were readable by humans, here we have on the right a piece of fabric produced by one of these machines, readable by humans as representations of nature, in a sense, what we're talking about is a modern phenomenon and not just a phenomenon of digital computing. Now, here we have Alan Turing, who's obviously one of the greats of the invention of modern computing. And this is on the right here, a teletype printout from the Manchester 1 computer on which he was working, building, designing, testing the thing at the University of Manchester after the Second World War. And you can see there we've circled a little bit of scroll writing by Alan Turing and said, how did this happen? So one of the conclusions that Alan Turing came to was that the amount of calculation that can be done is so phenomenal that ideas can be thought and things can be, results can be achieved, which wouldn't be possible with human reason alone. So what they were doing were finding these huge prime numbers, which by human calculation would be impossible to ever get to them. And here's the machine speaking back to Alan Turing. And really what the machine has is these phenomenal powers of calculation. So our key question then is, what is calculation? What does calculation do to meanings in the world? So this leads to our broad definition of artificial intelligence, meanings that are made with more calculation than could be possible without mechanical intelligence. So any calculation at all, which is bigger than humans could do by themselves without mechanical support. But what we've experienced really over the last few decades is another kind of artificial intelligence, which is defined by synergistic human-machine relations. So what we can do is we can have supervised machine learning where humans label things for the machine to count, to add up essentially, name things in the world, then the machine counts them, or unsupervised machine learning where the machine does a whole pile of counting and it identifies clusters or outliers, patterns in other words, and asks the humans to label the patterns. But the key actually is not the calculation, the key is the labeling. And the labeling, of course, comes out of human language, comes out of human meaning systems. So even in all these definitions of AI, there's calculation going on, but the real issue is the interface between the calculations and the human. So how far can we go with calculation? That's just the question we want to ask. And we want to answer that, again, our definition. We want to look at the limits of artificial intelligence as the limits of the transposability of meanings into quantity. We want to answer, address what these limits are and how it happens essentially. And I just want to mention a reference. This is a work that Mary and I completed last year. Actually, it's 2 volumes published by Cambridge University Press in 2020. We also have a website called meaningpatterns.net where we've been struggling with this question about the nature of meaning and the nature of semiotic systems which produce meaning, but also specifically about the systems for the production of digital meaning in the era that we live in now, the era of digital meaning and artificial intelligence. And we've identified 4 interesting things that happen in the digital world in this relationship of meaning to calculability. So firstly is the nameability of the world. So, here, there's a name on a bag tag there, CA09851, and if my bag gets lost, I can speak that name. And here on the right, we have a product, and it's not just any old sardine can, it's 4800, it's named uniquely in a system of identifiers. So what we have is we have these almost unspeakable names for things with an incredible degree of empirical specificity. Now, if you argue that what language does, it creates proper nouns, my name, Bill Cope, is a proper name, but there are other Bill Copes in the world. So what this does is we build identifiers, alphanumeric identifiers, which are incredibly specific to that particular flight or that particular brand of sardines and that which is there in the supermarket. But also these are names which are machine readable. These are objects which can speak their own name. My bag speaks its own name as it goes through the luggage system. And when I go to the checkout, the sardines speak their name as well. The second thing is calculability. We can count how many bags there are. We can count the sardine cans so we can put them more on the shelf when they've all run out. And one of the issues, one of the things that computing does is this elaborate processes of counting, which involve statistical processes, but also involve Boolean logic. So we can say yes and no, naught and one, on and off. And this is the moment when Claude Shannon, the man on the left there, when he finds an obscure bit of 19th century philosophy, George Boole's logic, and connects it with the fact that electricity can be on and off. But these are incredibly simple things, yes, no, on, off, 1, 0, So the elemental units of calculation are incredibly small. And the question is, how do these then become to be human meanings? The other thing we can do is in this world of calculation is we can measure things. So, you know, we can have sensors which count our steps. We can have sensors that tell us that a door is opened. So what we can do is that we have these forms of measurement which elaborate on our human experience of measurement, but often involve embedded sensors. If you like, if you want to think in grammatical terms, these are the adjectives and the adverbs of the new world. And if you want to think about it, natural language, actually, you know, the door's opened is pretty darn ambiguous, which door, where. And it becomes pretty ponderous to be incredibly precise about it. And, you know, hot, cold, fast, slow, we have these words for things, but in a sense, by numbering them, we end up with a degree of semantic specificity that we've come to really rely upon in the digital world. So what's interesting is that these historical processes that these processes that historically we used to consign to natural language, we become dependent on the accuracy and precision of these things, and also visualizations of those things, renderings, which give us immediately a more precise sense of what all these qualities in the world mean. Qualia is the word that's often used to describe these things. And the fourth thing we can do in the digital world is we can take these calculated meanings, the names of things, the calculations that we draw by adding up empirical things that have been named, the things that have been measured, and we can render meanings using digital means of manufacture. So here we are, you know, we see a letter on a screen, but in fact it's been pieced together with a pile of numbers. And behind this number A is actually a universal scripting system these days called Unicode. So there's actually the sound and letter A, or the Chinese character, or an emoji, or a whole pile of other human representations are behind this in abstract forms, but then they get rendered by piecing all these dots together. And in fact, it's this laborious process of, you know, the fifth dot from the left-hand corner, and then it's a pile of incredibly boring exercises in counting which produce this letter. And also the same counting processes produce image as well. So one of the interesting things about the digital modernity that we live in is this incredible convergence of image and text, because they're made of the same stuff. Old-fashioned books, you know, had separate sections for the pages that were produced by letterpress printing and pages which were produced by lithography, because the technologies for imaging and the technologies for rendering text were really quite different. So what's interesting is that in this digital world, we have this remarkable convergence, overlays all the time of image and text, because the technologies work on the same principles of calculation. That's our point. And of course, we can also do 3D printing. We can do computer-aided design, which helps us build buildings by conceiving three-dimensionality by calculation as well. So just to conclude, to add to that, what we can layer over these four forms of calculation is these various forms of machine learning. So supervised machine learning, we've got a pile of pictures, and people say, well, that's the sky and that's a car. In fact, you know, in little web authentication things, they're getting you to do this all the time. They're saying, show us the car, show us this, and whatever. They're giving you images, and they're both testing you to check that you're a human, but also the other side of the coin is they're using those for you to label images in the world, so the machine, when it sees a similar image, will be able to recognize it. So this is a kind of a synergistic human-machine relationship, which is supervised machine learning. Unsupervised is, as I say, you've got a pile of numbers which said, look, here's a cluster. What are all these pictures from the machine point of view all look the same. Look at all these pictures and tell us what's the same. Well, you give it a label when you do that. So these are the two. So in a sense, what distinguishes this narrow version of AI is that in the modern world, these very close human-machine relationships. Now, I want to move on now to the second point and sort of come to some conclusions and say, okay, what does this mean? What are the implications of all of this? Well, I don't really have the time to do it now, but what I want to mention to you is that in the two books I showed you earlier in our website, we've been trying to build what we call the transpositional grammar. So what's interesting about this world is we see the convergence and the overlay of multimodal meanings in the form of text, image, space, object, body, sound, speech. This is our kind of typology of what we call the forms of meaning. And every one of these can be digitized. Every one of these can be put into the same machines and thought through and processed. You know, some things a little less directly, body, for example, you know, reading biometrics, reading gesture, you know, yes, that can be done in a limited kind of way. Objects are represented in a mediated way via image or spatial representations. There's digital video and stuff. But so, you know, yes, there are complicated mediations which pull these things together, but every one of these things can be registered, in digital text, can be in the world of digital media, I'm sorry, can be represented. And what we want to do is that, you know, we've been very language bound in our humanities stuff, you know, the language turn and thinking that, you know, the meaning of humans, that humans make is the uniqueness of our species' capacity to speak and to write, the work of language. But what we argue is the fact that we make meaning in all these ways. And what we've been trying to do is build what we call a grammar of multimodal meaning, where across all of these modes, how does reference happen? So how does agency happen? And in fact, these 5 things, reference, agency, structure, context, and interest, we built a theory where we argued that all meanings all the time, whatever their form, are representing these things. And we've tried to build a grammar which is capable of interpreting this world of digital multimodality across all these modes, a common grammar for all these modes. So for example, what we might do is, let's take text, instead of a noun, a common noun and a proper noun, we say a proper noun is an instance and a common noun is a concept. And we can apply that to image, because in an image, a realistic image is illustrates an instance, whereas an iconic image represents a concept. Let me give you an example of that. I'm just taking one of these examples now to show you what I mean. So in text, you could have my name, Hilco, but also I'm a person, which is a concept. I'm an instance of that concept. In an image, there's a photograph of me, but if I'm walking around the airport and I see an abstract icon of a person, that says that's something I can do. I can go to a bathroom, or I can do something where people are in general. So in other words, what we do is that those same meaning functions, that's our other concept, occur across multiple forms of meaning. Anyhow, go to the books if you want a longer playing version of this grammar of multimodality, a grammar that we hope will work for the digital world. So moving on to posthumanism now. What does posthumanism try to do? And you're going to get a sense, I think, in a second, that I'm a little bit skeptical about posthumanism. So on the one hand, yes, we want to do this. Posthumanism is right to deflate the claims to superiority of human intelligence. There are all sorts of other creatures in nature that have sentience and have intelligence, and there are immanent meanings in nature as well. It's not as if we're the only meaning makers in the world. And of course, in this terrible moment of the Anthropocene, these are things which we need to take these things on board. We need to reevaluate our role as a species in the natural world. But there's another version of this posthumanism, which is what I call AI inflationism. The machines are going to be smarter than us soon. They might dominate us. But in fact, it's a kind of false modesty, because we created these darn things. And in fact, they have limits of their own. And some of the limits are limits that we made for them, if you see what I mean. So the image on the side, by the way, that's a kind of an in reference. I work at the University of Illinois, which is where some of the first computing devices in the world were built. In 2001: A Space Odyssey, the HAL 9000 is the computer which runs amok. So the film and the novel, 2001. Anyhow, here's what Freud says. You know, we've become a kind of prosthetic God. We've built these tools. And this was before computing, of course. All tools do this to human beings. And these tools give us cause to be anxious. So here are some sort of pretty terse conclusions, phrases that I've pulled out of stuff that we've been writing. Human intelligence and artificial intelligence are not the same. I quite like the idea of computing machines. And these things are just calculators. That's all they do. And what they do is they reduce the complex multiplicity of meanings in the world using, in fact, just two numbers, which in Unicode that they are, and using Boolean logic as well, layering that on top. And apropos of Freud, these become cognitive prostheses, remarkable powers of numbering and calculation, which really supplement the way we mean and we act in the world. But the limits of machine intelligence are the limits of the transposability of meanings into computable number. So if you'd like to know more about the work that we do, and you'd like to connect with us in one way or another, these are our various web presences. So on the left there, we have a platform we built ourselves as part of our work at the University of Illinois called Common Ground Scholar. You can go and set up an account there, and if you do, join the Meaning Patterns community, and we put regular pieces of writing and extracts and images there. We also have a Facebook page, and we also have a page on a Twitter handle down there on the left. So come and join us. I hope you found that an interesting kind of set of provocative ideas in a short talk. It's only just the tip of the iceberg in terms of what the issues are. So again, thank you for inviting me to be at the conference, and wishing